Welcome, everybody. So, number 42 is a classic swing problem. And it's one that College Board loves to do, and it's a classic physics problem in its own sense. You've got a 25 kilogram child sitting on a 2 meter long swing. It's released from rest when the ropes of the swing make an angle of 30 degrees from the vertical. Neglecting friction, find the child's speed at the lowest position. So, what we're trying to do here is figure out how fast she's going to be going when she's at the very bottom of her swing. To figure that out, we need to figure out how far she falls. In other words, the distance from here to here. What was her height change? She's converting gravitational potential energy into kinetic energy. And you might say, whoa, 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 this is impossible to solve. Well, it's actually not so bad. We know this angle here is 30 degrees. And so you can actually find this length right here, from this side to this side. And because it's a 30, 60, 90, that actually works out pretty well. This side of this right triangle is going to be root 3, or about 1.73 meters. And you might say, wait, how does that actually help me? Well, if this is 1.73 meters from the top down to this point, how far is it down from here? Well, it's just the difference between those two. This distance here, we know she's a total of 2 meters below the pivot point. And so if we subtract that, we'll discover that she is approximately, hold on a second, sorry, 2 minus root 3. Forgive me for a moment while I solve this. She's about 0.268, I'll go to 3 sig figs, meters below from where she started. And once we know that, we can actually solve this thing. Good old work energy theorem. She starts out with gravitational potential energy, mgh, and at the bottom, I'm going to set h equals 0 right at this height here at the bottom. She's just going to have kinetic energy, no longer any height. Just for convenience. Plugging in our numbers, her mass is 25. I'm going to do gravity is 10. The height she starts from, 0.268. And in the end, it's all going to be kinetic energy, 1/2 times her mass times v squared. Solving it, initial gravitational potential energy was 67 joules. And plugging it in, we get this. So that's the answer to part A. Part B, if her actual speed at the bottom was 2 meters per second, how much mechanical energy was lost due to friction? All right, so for part B, we can actually figure out what her kinetic energy is at the bottom. If she's only going 2 meters per second, we end up with 1/2 times 25 times 2 squared. Well, 2 squared is 4. Times 25, 100, times 1/2. It's 50 joules. So she only has 50 joules instead of, she should have started out with 67 joules. How much did she lose? Well, she should have 67 joules of kinetic energy at the bottom, but she lost, apparently, 17 joules. And that must end up as EDIS somewhere. And that's the answer to part B. She should have 67, but she only has 50. So she lost 17 somewhere along the way. I hope this helps.